Okay, in this example, what we're looking at is a graph. They gave us a graph and they're asking us to find part A, the domain and range of this function f. In part B, we're supposed to sketch the graph of the inverse, f to the -1 of x, or the inverse of f. Now, the domain is the smallest value of x you see to the largest value of x you see. That goes right along with the way we read, from the left to the right, smallest values of x to the left, biggest values of x to the right. Range, however, you have to think of it a little bit backwards, because if you think about the y-axis, the bigger numbers are at the top, the smaller numbers are at the bottom. So when you're talking about range, you have to read from the bottom to the top. So to find the domain, and also before we get started on that, I'll talk about this graph a little bit. I changed it a little bit from the one that's in your textbook. I put a filled-in circle here at this point. I put an empty circle here at this point to indicate that we're not including this point as part of the graph. Now, it would help to identify some word pairs, especially looking at what we got coming down the road. We need to find the inverse of this thing. And we've got a fairly accurate graph here. The x-axis is drawn and labeled, the y-axis is drawn and labeled, and a scale is shown. In other words, how much is a tick mark worth on the x-axis, how much is a tick mark worth on the y-axis. So the coordinates of this point here, the x-coordinate is 0, the y-coordinate is 1. And for domain range, all I really need to worry about on this particular graph is this point and this point. So if I find the x-coordinate of this point, here's 1, 2, 3, 4, 5, 6. So my x-coordinate is 6. My y-coordinate is 1, 2, 3, 4, 5, 6, 7. So that is the order pair 6, 7. Now, the domain will be, I'm going to put a square brace to indicate that we're including this point. The smallest x value I see is 0. The largest x value I see is 6. So I'm going to stop it at 6 and put an open parentheses around the 6, because this is an empty circle indicating that we're not including that point. We just get real arbitrarily close to it. The range, well, the range, we're going to start the smallest y value we see. Remember, you have to read the range from the bottom to the top. The smallest y value this function ever takes on is 0. The largest value it ever gets close to doesn't actually take it on, because the empty circle is 7. So my range is going to be the interval. Put a square brace around 0, and then we go to 7, put an open parentheses around the 7. That takes care of the domain range, so that's our answer to part A. Now, for part B, we're supposed to sketch the graph of the inverse of this function f. I'm going to use green chalk to indicate the points on the inverse. If you remember, inverse does what? It reverses whatever the function does. Mathematically speaking, it's going to reverse or flip-flop your domain range. It's going to reverse all your x and y coordinates. So the point 0, 1 is on the function, which means the inverse of that point, 1, 0, will be a point on the inverse function. Now, for the inverse, I also need to know the coordinates of this point here. So this is 1, 2, 3, 4, 1, 2, 3. So this order pair has coordinates 4, 3. If I find the inverse of that point, that will be 3, 4. So here's 1, 2, 3, 1, 2, 3, 4. And then the inverse of the point 6, 7 will be 7, 6. So here I'm at 6. One more gives me 7. And then 6 will be down here. Get a ruler and try and draw an accurate graph here. So, because this is just a straight line graph, it's really pretty simple. The inverse is going to look something like this. And this should be an empty circle, because once again that point is not included. Okay, so the coordinates of this point are 1, 0. Coordinates of this point are 3, 4. And the coordinates of this point are 7, 6. What I'd like you to notice about this is there is some symmetry, but it's kind of hidden. If you remember the identity function, y equals x, If I was to draw it as a dashed line, y equals x is just a line that goes through the origin at a 45-degree angle, then the symmetry should just jump right out at us. Okay, it's a little bit off because I had my ruler and my chalk a little bit too wide, but you can still get the idea. This line is symmetric with respect to the x-axis to this line, and it goes the same way. Okay, so there's functions and inverses.